All right, let me get a full screen so I can center the camera more easily. I'm going to do problems 1 through 71 odds test today. This is what you should have done for the following problems. So the first 30 problems here or so, I'm not going to talk about too much. They should be very familiar from the previous lesson set, so I shouldn't have to talk too much about concept and too much about mechanics. So it's mostly just looking at -2 and writing x plus 2. Getting rid of that, bringing in the 5, that gets us correlation. And from 5 to 10 is an increase of the y values by 5, and -2 to 12, 14. Now, I did that a little different than y2 minus y1, x2 minus x1. I said, how do you get from here to here? It's a little easier on the brain. So slope intercept, I believe, no, 3 coordinates. So I like to start with the x side of things, which is -14, and then I'm going to change going up by 17. So that takes me to 3, that takes me to 20. And then I've got my first y value, -33. I'm going to drop 50. So that's minus 17, another 50, minus 17, and then another 50. Well, positive 17, right? Let's see. Where the heck am I? Minus 33, excuse me. Minus 50 is minus 83. I might have made a mistake on my key. And minus 83, another 50 is minus 133. I think that's correct now, hopefully so. So 20, something's wrong here. I went up 14 from 13 because I wanted to check this by my last coordinate. So slow down, Jim. All right, starting at a y value of, no wonder, what am I saying? Oh, it's this problem. Yeah, minus 33. I'm looking up here for some reason. And I'm changing by down 50. So down 83 looks good now. Down 133, and now I plug in 20 into this equation. There we go. There's your 34, there's your 2 times that, so there's your minus 133. Move on. Let's get rid of this, make some room. I only got a half an hour here, so I got to come in under a minute for each problem, and I'm not necessarily doing that right now. Multiply by 10, clear the decimals, why not? Minus 22x plus 23 equals minus 74. Maybe that's just a little simpler. So I'm going to divide by 22x. So I would have taken a shortcut there. Add 74 to 23, 97. And we can see our answer 22 over 97. All right, so that one's done. Next one. I just changed the numbers on these tests. So if I'd seen that could have been reduced, I probably wouldn't have asked that. But let's clear the fractions. The experience I wanted you to have was clearing the fractions here. So 2 goes into 10, 5, that becomes minus 40x, that becomes minus 40, that becomes 6x, and that becomes 20. Now we can see that we got 46x on this side. Move the x's because you're going to divide. You might as well divide by a positive. Take 20 away. All right, let's divide by 2, and that's 23x. And so now we can see our answer, minus 30 over 23. All right, so that takes care of that. Not much I have to say here. You're just dropping that in and getting 15 minus 7, which is equal to 8. No reason to talk about that, I don't believe. Okay. Now, f of x. Well, f of x was 5, -5 times x, but I'm not going to write the x, minus 7. So no matter what you plug in here, the f function, the f calculation, asks you to multiply it by -5 and subtract 7. So what x are we looking at first on the test? F of f is this calculation, is minus 5x minus 7. What am I going to do to that input? So if I put x in here, that gets me minus 5x minus 7. That takes care of that part of that calculation. And now I have to do it again. Minus 5 times the new minus 7 is going to get me 25x, 35 minus 7, plus 28, I believe. Okay, going pretty fast here. I hope I'm not going to make too many careless errors, but this is definitely going to be a rush job. It's okay for me to rush when I'm not talking, but when I am talking to you, I find I start making careless mistakes. At this stage, you should have this memorized. You should not have to write parentheses times parentheses. If so, I encourage you strongly to look at these problems a little more carefully, looking for the patterns. All right, minus 35 doubles, minus 70x, plus 49. All right. I like to write these in columns. You've been watching the other videos, so I've got a minus 8x to the fourth. I've got a positive 12x cubed. I've got another minus 8x to the fourth. Make sure negative times positive, yes. Okay, minus positive 10x cubed. Okay, now we're combining these, so like terms, minus 16x to the fourth plus 22x to the third. And if you're writing your test corrections and you got this wrong, I fully anticipate seeing this on your corrections. Showing how you do it. I think we want minimum. So what do I see? I see I'm starting at 3. I'm going down at 3, but it's cup shape up. So therefore I know I have a positive minus b over 2a, which in this case is a half. And if I drop a half in here, I get minus 1. If I cut that in half, I get minus 1/2 plus 3, a little shortcut there. Sure looks like I'm at 2.5. And I think we should write that as 5/2. And 5/2 is what I want to see on your answer key. That's the minimum y value rating. Unless I made a careless error, which is quite possible. I will talk about the cubic a little bit here, because I want to put it in graphing form to explain a little something, but I think I wanted, I don't know, point of inflection, rate of change in point of inflection, and so I might as well just graph it. So 45 divided by 3 times 15 is minus b over 3a, and that's 1. So therefore I have 1. 15 minus 45 is minus 30. Notice the 3-to-1 ratio and opposite. That should ring a bell from the quadratic experience. Plus 5 minus 4, that's a nice easy number to work with. You just work with the coefficients. Minus 30, minus 25, minus 29. All right, so what am I doing at that instant? C minus 3ah squared. C is 5. Minus 3, a is 15. H is 1 squared. Looks like I'm going down at 40-to-1. Going down at 40-to-1. Going pretty steep. Therefore, I have a cubic that looks like this. 1,29. And I know that my y-intercept is -4, so that's over here. Oops. Oh. +1. I think I said maybe I made a mistake and maybe it was -29, because that y-intercept sure looks like it should be there. That's the helpful thing. If you know something about the y-intercept going up at 5-to-1 at 0 gets me -4. That's helpful to me. It helped me find the sign error here. Minus 30, minus 25, minus 29. But talking to you, I forgot to write that. But knowing this helped me catch it. Yep. And so in graphing form now, I have everything for graphing form. Graphing form is 15x minus 1 cubed plus, minus 40. X minus 1 minus 29. Let's talk about rates of change. All right, let's hide that from your mind's eye. That's a cubic that looks like this, and it's changing. Minus 40 goes through 1. They both go through x equals 1. Looks like that. Well, if I add up the y values along with minus 29, that's what's going to get me each y value from each contributor. Minus 29 gets me this picture. But why do we have this? Just want to talk about that for a minute. Well, this is a constant rate of change. I'm always going down 29-to-1. That's a slope of 0. That is not going down at 29-to-1, which means at some instance, I'm going up at 29-to-1 here. The constant's not going to make something flatten out, right? The cubic is flat there. The cubic at the point of inflection is flat. Has to do with surface area of the cube, because that's how a cube changes. Add some surface area to the exterior and you got more volume, because you're adding that exterior surface area implies there's a little bit of height. Now, get carried away here. So it's the interplay of the roots, which is why you see the opposite of -40. And I don't want the minus sign. That's why you're seeing +40. Because I got to find a place where this is going up at 40-1. And what am I measuring from? I'm measuring from the number 1. And 3a comes into play. 3 times this number does come into play because multiplication affects roots. All right, so we deepened the conversation just a little bit. Hopefully I answered the questions that needed to be answered. Let's see, how am I doing on time? I got to check the time. Okay, I got 15 minutes. All right. So 2x squared plus 5 equals 0. I'm just seeing if you remember the plus minus, right? And this is going to be -5. So 5 halves I. That's what I want to see. That's what I want to see. The whole purpose for that problem. All right, this is bingo, bango, bongo. I think I got to move this a little bit. I'll move it back. Bongo is x minus 2, x minus 5. And I like to leave it like that because you never know if you're going to get some cancellation. So 5 times x minus 5, 5x minus 25. X minus 2 times 4, 4x minus 8. And now hopefully we can see 5x minus 4x minus 25. Was that what it was? Minus 25 plus 8. That distribution, minus 25 plus 8, minus 17. That factor is not going to get canceled. So if you multiply it out, you better get the following or there's an error. Okay, you can leave it like that for the denominator. All right, so let's get rid of that. Gonna pick up the pace here. All right, so squaring, binomial squaring, 8b5 becomes b10. Doubling that product is just counting the number. -1 times 3. -3 becomes -6. Exponents stay the same. Always squaring. I almost said minus there. Squaring a negative is a positive. Squaring a positive is a positive. It ends as a positive square. Okay, let's get rid of that. Come in under distance. Ask yourself, how far is it from -4 to 5? 9 units, square it. How far is it from 2 to 6? 16 units, add it. Take the square root and you're done. The distance between those 2 points was the square root of 97, near 10 units. That takes care of that. All I did was see if you could figure out that this means y varies directly as x and inversely as z. I'm not going to take the time to plug in the x, y, z's. Okay, but you have to identify joint variation. Could have been said y varies jointly as x and inversely as z. Then it should be able to be doable. Okay, just trying to get you to memorize the quadratic formula from a different perspective. NBC, I could have used ABC, I could have used CBS, FBI, CIA. Minus B, plus or minus the square root of B squared minus 4NC over 2A, which in this case is 2N. I'm looking to see if the fraction bar is all the way across. Okay, a lot of people do this. And that is incorrect. All the way across. Okay, so it takes care of that. But coming in under a minute, I don't know. All right, so I see a square root with a negative, so I know it's imaginary. And now I look at square roots. Well, I know the number 9 sits in here. 9 times 5. All right, so that becomes that. 9 becomes that. 5 stays inside. Next to the 3 becomes that. Oh, I'm doing square roots, excuse me. Square roots. Thought I was doing cube roots for a minute. So 2 goes into 3. 1 comes out. We don't write the number 2, but it's in the mind's eye. 1 stays in. Now you check it by doing 1 times 2 is 2 plus 1 is 3. How many times does 2 go into 81? 40. 40 times 2 is 80. I need 1 more. How many times does 2 go into 9? 4. 4 times 2 is 8. I need 1 more to make 9. All right, very quick. We didn't have a lot of time to up your skills in factoring from Algebra 1. So really just fundamental Gotta be able to rewrite this as x plus two, x minus two. Over 5 times x plus two. Final answer, x minus two over 5. So if you didn't get that, I expect to see that on your homework corrections. And my saying this right now, if I don't see it, I know you didn't do your homework. Okay. Hate to say it that way, but. All right, just because of time, I'm gonna do this. I'm gonna move the k. Gone. I'm gonna divide by a. Gone. I'm gonna take the plus minus. Belong, and I'm not gonna write any kind of I over here. I don't know what 1 minus k is. Could be positive or negative. Positive h minus h. And there's your x value solving that equation. All right. 16 over 14. I might as well do that right now. 8 over 7. Now we're going to move all the negatives into the other location. So I see a negative. I see a negative. I see a positive. I'm going to keep it there. I see a positive. I'm going to keep it there. So this is 8 sevenths. 8 sevenths A with a B. That's what that one is. Okay. All right, so on the last test, I gave you root 11 times, so I'm planting a few problems here. Again, if this answer, if that was square root of 11 times the square root of 11 times the square root of 5 on the last test with an answer of 11 root 5, I'm having a hard time thinking that if you're doing your homework, that you can't manipulate that to be 5 root 11. But we'll find out, because I'll be talking to you. 1 over m could have been written as m to the minus 1. We talked about this a lot in class yesterday. Log m is asking the question, I want in the parentheses the exponential activity, and my answer is that exponential activity. I think I see the exponential activity. And you'll write this out in separate steps, but I'm in a hurry. Okay? I forgot what I had. 1 over m. I hope it was positive 4 out here. I don't even remember now. All right. This is what I'm doing. It may be different than what's on your test. All right. So this was negative 1. This was 1 over m. Talking to you here. So m to the minus 1. All right. And I may have the wrong exponent from the test, but if it was minus 4, then our answer is going to be minus 4 times 1 is positive 4. And now I have who's in Grant's tomb, and my answer is who's in Grant's tomb. Well, that was a nasty analogy. All right, so 4x squared plus 16x plus 1. I think I asked you to sketch it, so cup shape up. I know 1 is on the increasing side. Whoop, over here on the increasing side is 0, 1 with a slope of 16 to 1. And we've analyzed that numerous times in class, which means I have a negative x value here to the left of 0, right? To the left of 0 is a negative, so 16 divided by 8, it must be negative 2. And therefore, negative 2, negative 32. There's the shortcut, cut that in half, plus 1 is negative 15. And I think we have the sketch. All right, now we're going to sketch a line in point slope form. So why don't I show you a point, a slope, and leave it at that. Obviously, you could put in more data. Negative 1, 6, negative 1, 6, and comma 6, excuse me. And I'm decreasing, so we'll leave that on this side. And I'm going down at 3 and going over to 5. There you go. I gave you a slope. I gave you a point. I gave you slope point form. Okay. I think all I asked was for the rate of change at the point of inflection, just to get you to do it again. Make you say c minus 3ah squared, which in this case is c is minus 2, minus 3, a we have, which is 1, but we don't have h. You remember how to get h? Minus b over 3a. All of this should be written on your corrections. Minus b, positive 4, over 3 times 1 is 3. Ooh, would I really make you do that? I guess I did. So we got to put it in. At least I'm not having to drop it in to find the y value. All right, so that's minus 2, minus 3 times 8 ninths. That's not so bad. Minus 24 ninths, so I want ninths, so I got minus 18 ninths, minus 24 ninths. And that's going to be minus, what? 42/9. It's going down a little bit between -4 and -5 to 1, right? We're in between that at the point of inflection. All right, I didn't mean to do this. I don't want you getting hung up on, just elementary school math. I'm talking concepts here. What's the period for this? The period for this is determined by the angles. All right, where do I start my graph? What angle is user-friendly? Well, I think the user-friendly number here is 12. 12 divided by 2 is 6, 6 minus 6. So on this sine function, I'd be in the middle at 12. The question is, where do I end up? Well, I end up when this equals 2 pi. When x over 2 minus 6 equals 2 pi. Well, I know it's going to be 12 plus something. So why don't I do that? 12 plus something, and then I don't have to worry about that. But I do have to worry about 2 times 2 pi. I guess that's 4 pi. So I guess the period is 4 pi. I start at 12 and I travel that much distance, which is about 4 times 3.14, roughly 12.56. Okay. Yeah, I could have just doubled 6.28, right? That would have been easier. All right. Anyway, oops. Sorry there, Walt. What's the shortcut? The shortcut is identifying what you're multiplying x by. And some folks need to see that, 1/2. And if you take that 1/2 and divide it into 2 pi, you're always going to get your period for these functions. All right, so what's the range? Oh, I got an equation I got to solve. Am I going to come in underneath the time I need? Barely. All right, I might have to cut this a little short. So this is all about heights. Sine x is height in the unit circle. And my heights are going to be here, I believe, and here. I believe that's where they are because I see √3/2. And the sine function equals √3/2. Again, we keep talking about what does that stand for. In this case, I'll do degrees. At 60 degrees, I get √3/2. And at 120 degrees, I get √3/2. Those are your two answers. And you communicate that to me on your test. What's the range? Well, I know the cosine is a number factory that kicks out numbers between +1 and -1. Okay, so there's +1 and -1 so far, but I'm multiplying by 5. That means I'm going up 5 and down 5. But I'm adding 6 to that. So that makes this 11. And this one, that one was the 11. What was the midline? Well, I'm adding 6 here. 6 to -5. I think I mislabeled that. That was -5, right? Up and down 5. Yeah. Okay, so the range would have been easier. Midline, it's really 6 plus or minus 5. That's what you're doing. So you're going from 11 to -1 to +1, excuse me. 1 to 11 is the range of this function. And it should be a y equal statement. Less than or equal to. All right, sorry. Let's see. I got maybe time to do this. Then I'll run upstairs. All right, so I've given you a handout. We've looked at all the table values. We've looked at numbers like 7. Well, we haven't looked at 7, but that's 49. We have looked at what 7.0001 gets you. You try it. If you've been looking at this, you're going to get it right. 49.00140001, I believe. 14 divided by 0.0001 gets us a 14-to-1 rate, which is double the 7 value. We've done that with all kinds of numbers. So what determines rate at any instant? Doubling the x value. All right, so at 4, my slope is 8. Here's the tangent. At 4, I'm going to write x minus 4 squared, right? I'm gonna write, I'm sorry. At 4, I'm just doing x squared. So 4 gets me 16. I should have done that to show you why I'm saying x minus 4 plus 16, because it goes through that coordinate. So I need the coordinate at 4, 16, and I need the rate of change, 2 times 4, 8. And that's the tangent. I'll just put a big T there. All I did was ask you to see if you did know how to write y inversely as x, and then work with it. Okay, so we've been working with the rules of logs. Maybe you did this and never even thought about 0.7 plus 1.6 equals 2.3. Maybe you're doing that now. Or maybe you have to write 10 as 2 times 5, which is e to the 0.7 approximately. E to the 0.7 times e to the 1.6, and that's approximately e to the 2.3. And then what's the ln of that? The ln is basically asking who's buried in Grant's tomb. What do you put on top of E to get what's in the parentheses? Well, right there. That's what you put on top of E to get 10. Okay, so that was the approximation. Okay, this was a Algebra 1 word problem. I'm trying to sneak in there before the end of the term. If you have a total length or a total number of pounds for how many pounds of candy you want, so let's call this 60 pounds of candy, and you take some of the candy away, right? Well, you're subtracting this from 60. And let's just say it's variable how much you take away. Boom. That's why I'm writing, well, I guess it was 30 pounds of candy. That's why I'm letting X equal a certain amount of those 30 pounds at 40 cents, and then 30 minus X at 70. And I'm just looking for the equation. And I don't know how much time we're really going to spend on that. All right, last one. I'm just going to do it from a graphical standpoint. You may have done it at a sign change standpoint, but I'm looking at the exponents. At 0, it's to the first power, so I'm going to get a sign change. -5, I'm going to get a sign change. +3, I'm going to get a sign change. All right, so I know the end behavior of these polynomials. Positive, positive, positive. Whoa, and at 3, I've got a linear change. At X, I have a linear change, and at -5, I have a cubic change. So that's what the graph looks like. When am I greater than or equal to 0? Well, certainly -5 to 0 works. I've just got to write the answers at this point with a bracket. Union 3 also works. To infinity. Can't bracket infinity. All right, I got to get upstairs, giving a test in 5 minutes. Toodaloo. I'll do the second half of the test later today. And then the second half's got the rational functions, more graphing, etc.